Hi guys, welcome to our channel, The Tutor. This is the second video from electrochemistry, and it would be better if you watch the part 1 and come here. In the first video, we have seen about electrochemical cells and galvanic cells in detail, and then we saw about measurement of electrode potential. And today we are going to continue with the Nernst equation. Let's see the use of Nernst equation first. We already know how to calculate standard electrode potential. That we discussed in the last video. And we also know that standard electrode potential is calculated when the concentration is unity. Here comes the role of Nernst equation. That is, when the concentration is not unity, we have to put the concentration term and get the answer by the Nernst equation. First of all, I'll read out the Nernst equation and then we'll see the abbreviation for everything. E cell equals A naught cell minus RT by NF into Ln concentration of metal by concentration of metal ion, and concentration of solid metal is taken as unity, so the final equation is Ln 1 by concentration of metal ion. Let's see the abbreviation for every term one by one. First of all, E cell is the one which we are going to calculate for that particular concentration, and E naught cell is the one that we got from the standard electrode potential. R is gas constant, T is temperature in Kelvin, F is Faraday constant, and N is the number of moles of electrons transferred in the redox reaction. And Mn plus in the square bracket is concentration of that metal ion. Next we are going to see Nernst equation for Daniell cell, and it will also be an example for how Nernst equations are being used. So let's see how. The equation is E cell equals E naught cell minus RT by 2F Ln concentration of zinc ion by concentration of copper ion, and RT by 2F because N is 2 here, as number of moles of electrons transferred here is 2. In NCERT they had given a small derivation of how Nernst equation are being applied for two redox reaction combined, and if you want to see that, or I'll tell you a trick, and the trick is this is the whole reaction for Daniell cell, that is zinc metal plus copper ion gives zinc ion plus copper metal. So if you know cell equation, in the Nernst equation inside the Ln put concentration of ion in the product by concentration of ion in the reactant. Now let's see how Nernst equation is used for any cell, that is, if any random reaction is given from some random cell. Let's see how Nernst equation can be applied for that particular cell. Let the given equation be small a times A plus small b times B reacting to give small c times C plus small d times D. For that, the Nernst equation is E cell equals E naught cell minus RT by NF into Ln concentration of C to the power small c into concentration of D to the power small d by concentration of A to the power small a and concentration of B to the power small b. And now we are going to see electrochemical series. It is a series in which the top elements act as oxidizing agents and the bottom elements act as reducing agents. This series is pretty important, so go through it once or twice and have an idea of where the metals are placed in the series, whether oxidative or reductive. That is at the top of the series or bottom of the series. And now let's see how equilibrium constant can be found from the Nernst equation. If we place zinc metal in the copper ion solution, obviously we know that zinc will displace copper ion to give zinc ion. As the time runs, zinc ion concentration will keep on increasing and concentration of copper ion will decrease. So the voltage of the cell will also decrease, and at one point of time the voltmeter will give 0 reading, and that is the point when equilibrium is attained. If you are able to recall from the equilibrium chapter, the value of Kc equals product of concentration of product by product of concentration of reactant, and raised to the power of stoichiometric coefficient. Now we got the value of Kc from the Nernst equation by just modifying few things. That is, we put E cell equals 0 as we are in equilibrium state, and inside the log we replaced the concentration of product by concentration of reactant by Kc, as we saw the definition for Kc just in the previous slide. And one more thing to note here is that previously we were using ln, that is natural log, in the previous Nernst equation, and now we used log instead of ln. So the relation is ln equals 2.303 log of whatever value you have inside. And now let's see the electrochemical cell and Gibbs energy of the reaction. In this, the questions will be only from the formula. So just try to memorize this formula, that is del G equals minus NFE cell. And now listen carefully. At equilibrium, the Nernst equation becomes like this, as we saw earlier. So if you substitute this A0 cell value in the del G formula, you get this. The last del G formula, that is del G equals minus RT into ln K. So that's the end of this video. Thank you for watching this video, and don't forget to share this video to your friend who didn't understand this topic properly. Bye.